Formulas, formulas, formulas. We're going to learn about some more formulas today, as it's a very useful tool to be able to find the surface area and volumes of spheres. As spheres are all around us, many professions use them, and they're in basketballs, soccer balls, any sports. Most round sports balls are spheres, and we're also looking at something that we live on called the Earth, is sometimes explained as a sphere. So our formula that we have today that we're going to be looking at is the surface area equals 4 pi r squared. So 4 pi r squared is the surface area equation for a sphere, so everybody should have that in their notes. So here's the first question. The diameter of a baseball is approximately 3 inches. So in our surface area equation for sorry there, 4 pi r squared. Do we have diameter in this equation? No, we don't. I know that you're screaming that out at me. But we don't have diameter in the equation, but we do have radius. So we are able to get the radius from the diameter, and the reason is we all know that the radius is half of the diameter. So the diameter we get out of the problem is 3 inches, so our radius must be 1.5 inches. Okay, everyone? So let's fill that into the equation. So 4 pi r squared, so 1.5 inches squared. So when you do this calculation, everyone, you're going to get 28.2743 inches squared. Now, this is an imperial unit, so do we use decimals? No. We'll just round up and say the surface area is approximately 28 inches squared. Here's another one which requires us to rearrange the formula. We're given that the surface area of our sphere, of the ball, is 250 square inches. I get that. I see surface area is 250 square inches of the soccer ball. They want to know the diameter. Again, diameter is not in our surface area equation, but radius is. So our radius is. So we have to rearrange for our r here to get an equation for r. So since 4 pi is multiplied, we divide. 4 divided by 4 is 1, so we can get rid of those. Pi divided by pi is 1, so we get rid of those. So we have surface area divided by 4 pi equals r squared. How do we get rid of the squared here? Everybody knows that we have to square root both sides, so you get the r equaling the square root of surface area divided by 4 pi. So we're going to go up here to fill this in. So my surface area is 250 inches squared, so squared inches, divided by 4 pi. So my radius actually equals here 4.46 inches, which is approximately, we can write in fraction form 4 inches, or you may round up to 5 inches here. But do we really want to round up here? So we'd probably round up to 5 inches here for a rounding. Do we really want to round up to 5 inches here? If we have to multiply by 2 to get the diameter, do we want to do our rounding at the radius? The answer is no. We want to leave the radius in the form, in the decimal form until we get the diameter. So let's not round right now. Instead, let's multiply by 2 to give you your diameter, which would be 8.92. Now that's and that's inches. Now that's approximately 9. So if you put approximately 9 inches, it's not the end of the world. But what we would rather you do when you're dealing with surface area and volume, you are able to round. But sometimes when you're dealing with these radiuses and diameters, which are actual measurements, not overall measurement like surface area or volume, we want to be very precise. So let's put 8 and 9/10 inches. This way we're using a fraction, not a decimal, to represent an inch. And we are left with 8 and 9/10 of an inch. So we have a fraction instead of a decimal. So more equations. Another equation that we're looking at today is the volume of a sphere, which we have right here. Another important equation that you should have in your notes, and I would be really happy if you actually put these in your notes, so that you have volume equals 4/3 pi r cubed. Sorry if I said that at the beginning, but you can see it right here is volume equals 4/3 pi r cubed. This is the formula you use to find the volume of a sphere. So let's try to do a problem here. So volume of sphere equals 4/3 pi r cubed. So we're given the diameter here. The moon's approximate is approximately a sphere with a diameter of 2,160. So we don't have diameter here, but we have radius, so we divide that by 2, and you get 1,080 miles. So we're going to use that in our equation, and very simply, we're just going to insert it into the equation here. And when you do that, you get the volume of the sphere equaling 5276669,286, and then there's a decimal and a bunch of numbers after the decimal. You know, when you have a number this large, remember that we should be using scientific notation. If you haven't used scientific notation yet, here's a quick example on how you do it. You only want the first 2 digits of the number left. And you move the decimal, and you're going to multiply 5.2 times 10 to the power of something. You know, you find out what the power of it is by moving the decimal in front of the 2. So we go over 1, 2, 3, 4, 5, 6, 7, 8, 9. So we go 5.2 times 10 to the 9 miles cubed. So if you rounded this number, that would be okay to a certain numbers of miles cubed, but scientific notation is the preferred method of representing that. If you guys don't know scientific notation yet, it is something that we will review on Monday once I get back. The last question I'm going to do today is actually a tougher question. It is about a hemisphere. Now, when you think of a hemisphere, you should think of the southern and northern hemispheres of the Earth. So the southern hemisphere is half of the Earth. The northern hemisphere is the other half of the Earth. So they're half of the sphere. Hemi is half of a sphere. So they're asking us to find the surface area of a hemisphere and a volume of a hemisphere. And they're asking us to round to the nearest tenth, okay? So what I'm going to do is we're going to have to look at what a hemisphere looks like. So a hemisphere looks like this. So if you look at this hemisphere, when we're looking for surface area, we kind of have 2 things we're looking at here. It has half of the regular surface area. So half of our normal surface area, so our normal surface area formula is 4 pi r squared. Plus, it has this circular portion right here. that I'm coloring in black here, this circular portion right here. That circular portion is part of the surface area of a sphere, so we must add that on. It's a circle. So when you split a sphere in half, you're left with a little bit more surface area than just half. You do have that circle there, so we do have pi r squared. Now, is r going to be the same for all of them? Yes, r is going to be the same for all of them. So our surface area equals 1/2 4. So if you multiply 1/2 by 4, you're going to get 2, correct? 2 pi r squared plus pi r squared. Now, if you have 2 pi r squared, you can also put this, you have 3 pi r squared, but you can leave it any way, which way that you like. So if you just fill everything in here, the radius, which is 8 centimeters, you'll end up with your surface area equaling 235.6 centimeters squared. So this is a fine way of doing it. Just remember that when you do have the surface area of a hemisphere, you do have to add, it's just not half of the normal surface area of a sphere, you do have to add that extra circle. So, what is the volume of the hemisphere? Now, the volume part is quite easy because there's nothing else to add. So, it's actually half. It is half. So, the volume of a sphere, we all know, is 4/3 pi r cubed. So, the volume of a hemisphere would be 1/2 times 4/3 pi r cubed. Now, 1/2 times 4/3, we can reduce this because the 4 divided by 2, so we can rearrange this. So 4 divided by 2 is 2. So you're left with 2/3 pi r cubed. So 1/2 times 4/3. So these can cancel out to be left with a 2. 4 divided by 2 is 2. Another way that you could look at this cancellation is by actually doing 1/2 times 4/3, which equals 4 divided by 2 times 3, which is 6. We can reduce this fraction by dividing the numerator and denominator by 2, giving you 2/3. Okay, so I hope everybody understands that. If you don't worry, we can explain it on Monday again and come to extra help Monday morning from 7:30 until 8:15 or Monday at lunch. So when I fill my radius in here, I go 2/3 pi, and I'm going to fill in the 8.0 centimeters cubed there. And then when I put that into my calculator, very brightly by pressing the pi button and by not putting in 3.14, so we are using the pi button here again, you will get 1,072.3 centimeters cubed. So that's our final answer there. I hope you guys understand surface area and volumes of spheres now. On the next slide, I'll be showing you your homework that you'll have to do for the remainder of the period. Okay, so you guys have a lot of time left. So I'm going to give you 6 questions to work on, 3, 7, 9, 13, 14, and 21. On pages 50 to 51 in your textbook. So please work hard for the remainder of the class, for whoever is watching you guys today, and have a great day. So I'll talk to you tomorrow, and I'll see you on Monday. For most of you, some of you I will not be talking to tomorrow, but for 10C-1, I believe, I do have another voice class with tomorrow. Everybody else I don't. So try these questions. If you don't understand them, please come for help on Monday morning or Monday at lunch. Thanks and have a great day, guys.